AP Calculus AB, Unit 10, Day 8, Office Hours. The answers you should have checked because you're doing them both two ways, and you should do them on your calculator both ways. And if they both come out the same, then it's probably right. If not, it's probably wrong. One of them is wrong, maybe both. So we'll go ahead and do them together. So part A is going to be dx. That's vertical slices. So we did this in the notes yesterday. So, draw the reflection. If you're going to try and fit both of these on the same picture, you just got to try and keep them apart, I think, to be the most successful. So the volume of a disk is pi r squared dx in this case. It's a vertical slice. And so that's your radius. It's going to be y top minus y bottom. And y bottom is just 0. Y top is the y coordinate on this curve in terms of x squared. The limits are going to be 0 to 4. So that's your answer. And then we're going to plug it into a calculator. I'll do that in a second. And then the next one, part B, is going to be dy, which is going to be horizontal slices, which is going to be parallel to the axis of rotation. So you're going to get shells. And shell is 2 pi r h, in this case dy. Don't memorize this. If you slice it open, if you slice the shell open, here's your shell. If you slice it open, it's a rectangle. Base times height. The height's the height of the shell, but the base is the circumference of the shell originally. That's where 2 pi r comes from. And then thickness gives it 3 dimensions. So it's going to be 2 pi. The limits are going to be 0 to 16. The radius is y top minus y bottom. Now, y bottom is 0, and y top is just whatever y value we're at. It's just y. The height depends on the curve. So it's x right minus x left. Now, x right is always 4. X left, in terms of y, take square root of both sides, plus or minus. So x equals plus or minus square root of y. We want the positive one because it's the right side of the parabola. So it's going to be square root of y dy. That's it. So if we plug these into our calculator, we check these out. Pi math 9, x to the 4th, comma x, comma 0, comma 4. That gives us 643.398 rounded trunk to 3 decimal place. Actually comes out the same this time. Try the other one, 2 pi math 9. We put x's in for the y's, parentheses 4 minus the square root of x, close, close, comma x, comma 0, comma 16. And we get the same answer. Good sign. Okay. Okay, next one. Let's draw the picture. So we have this. It's going to get rotated to here. So there's the other half. Now, A, we're going to do dx specifically, right? So that's going to be a vertical slice, which is going to be a disk washer because it's perpendicular to the axis of rotation. So I'm going to try and write everything over here, a little r. So it's going to be, there's a hole in it. So it's going to be pi r squared dx minus pi little r squared dx. And we're going to integrate it. Limits are going to be the x direction, 0 to 2. Both of these are y top minus y bottom, right? So y top is the y coordinate of this, 2x. Y bottom is 0 for both of these. It's right here. And then 0 to 2. So then the little radius is y top, which is this guy. X squared minus y bottom is 0. There you go. That's your setup. That's the washer method. Okay, B is going to be dy. So that's a horizontal slice. So I'm going to try and put it over here away from this stuff. And it's parallel to the axis of rotation. So it's going to give you shells. The volume of a shell is, slice it open, 2 pi r h, in this case dy. So the limits are in the y direction, 0 to 4. The radius is y top minus y bottom, and then y bottom is 0, and y top is just whatever y we're at, so it's just y. The height depends on the curves, x right minus x left. Now we need to get this x right in terms of y, so that's going to be the square root of y minus y over 2. That's the setup down, right? Because if you get this, solve this, square root both sides, then x right is going to be the positive square root of y. And over here, if you solve for x, you get x equals y over 2. So let's plug these into our calculator, see what we get. So we're going to get pi, math 9. I'm going to go ahead and 4x squared, simplify it a little bit, comma x, comma 0, comma 2, minus pi, math 9, x to the 4th, comma x, comma 0, comma 2. And we get 13.404, round truncated 3 decimal accuracy comes out the same. I'm going to try the other one, 2 pi, math 9, x, parentheses, square root of x, minus x over 2, close parentheses, comma x, comma 0, comma 4. Same answer. So pretty sure we did it right. We get the same answer on both of them. Okay, next one. Next one looks kind of similar to the last one, but it's being rotated around this kind of offset rotation. So draw it. Now for part A, we're going to do dx, which is vertical slice. So I'm going to put it over here, and we're going to get disk washer method, right? So we have a big radius and we have a little radius. They're both y top minus y bottom. Y bottom for both of them is -2. So the volume is going to be pi big R squared dx minus pi little r squared dx. Integrate. So we're going to go in the x direction 0 to 2. The big radius is y top, which is 2x, minus y bottom, which is -2, squared dx. Little radius is going to be y top, which is along that parabola. It's going to be x squared minus y bottom, which is -2. Don't forget the squareds. So that could be your setup. You can clean it up a little bit. You can change those plus pluses. That's all I would do. B is going to be dy, which is going to be horizontal slices parallel to the axis rotation, which are going to give us shells. So I'm going to just draw one shell. The formula for it is 2 pi r h dy. We're going to integrate in the y direction from here to here, 0 to 4. Don't start down here at -2 or something like that. Now the radius is y top minus y bottom. Y top is whatever y value we're at minus y bottom, which is -2. So that's going to be y plus 2. So the radius of a shell is always x or y plus or minus number. That's it. None of the curve stuff. The height depends on the curves. That's going to be x right minus x left. We need x right in terms of y. So that's going to be plus or minus the square root of y. It's going to be the positive because it's right half of the parabola. X left is going to be y over 2. So it's going to be square root of y minus y over 2 dy. That's our setup for that. So now we can check our answers. Plug them both into the calculator. See if they give the same thing. We have pi, math 9, parentheses 2x plus 2, close parentheses squared, comma x, comma 0, comma 2, minus pi, math 9, parentheses x squared plus 2, close parentheses squared, comma x, comma 0, comma 2. We get 30.159, round truncated 3 decimal place actually comes out the same. 2 pi, math 9, parentheses x plus 2, parentheses square root of x minus x over 2, close parentheses, comma x, comma 0, comma 4. This one's taking a little longer. Keep throwing square roots and stuff in there. 30.159. Perfect. Okay. All right. Best way to get good at these is just do a bunch of these. Okay. So part A, we're going to do dx. Let's draw this guy. I'm going to try and get the corners down and then connect them. That's it. Nothing fancy. So dx is going to be vertical slices. I'll put that kind of over here on this edge, and we're going to get disc washers. No surprise, because, and you should know what kind of slice you're going to get, because if you don't, then you might do weird stuff. It's perpendicular to the axis of rotation. You should get disc washers. So it's going to be pi r squared dx, but there's a hole, so we get subtracted pi little r squared dx. I'm going to integrate it. In the x direction, 0 to 2. So we have this big radius, which is y top minus y bottom, and y top is 20, and y bottom is the y value on this bottom curve. Well, I don't need to do that. It's just me x squared dx minus pi 0 to 2. The little radius is right here. It's also y top minus y bottom. Y top is 20, and y bottom is the y coordinate on this curve in terms of x, which is the square root of 8x. So that's the setup for that one. I'll come back later and calculate on the calculator. B is dy, so that's going to be a horizontal slice. I'm going to put that over here, trying to avoid it crossing these guys, and we're going to get shelves because it's parallel to the axis of rotation. 2 pi r h dy. The limits are going to be in the y direction down here. It's always based off this region, 0 to 4. The radius is here. Y top minus y bottom. So y top is 20. Y bottom is just whatever y value we're at. The radius of shells is just x or y, wherever we're at. The height, which is down here, depends on the curves. X right minus x left. So x right in terms of y would be the positive square root of y. X left would be y squared over 8. If you solve for x in terms of y, you'd square both sides. Y squared divided by 8, y squared over 8. So it's going to be the square root of y minus y squared over 8 dy. So that's your setup. So now we can check our answers on the calculator. So the first one's going to be pi math 9 parentheses 20 minus x squared close squared comma x comma 0 comma 2 minus pi math 9 parentheses 20 minus the square root of 8x all inside the square root, close the square root, close parentheses, squared, comma x comma 0 comma 2. And what do we get? 304.943 or 304.944. Now don't just assume, oh, well, they're both going to be the same. Double check it, because you guys need to get practice with this stuff. 2 pi, math 9. Some of you guys are going to set these up perfectly on your next test and get all the decimals wrong. Get all the calculations wrong, because you can't use your graphic calculator. 20 minus x, square root of x, minus x squared divided by 8, close, comma x, comma 0, comma 4. I mean, it should be a fast activity, and you should get right every time. But it takes practice. Same answer. Good sign. Round or truncate, 3 decimal. Actually, I always truncate. It's hard to mess that up, but feel free to round. Just don't mess it up. Okay, next one is being rotated around this vertical line, the y-axis. So part A is dx. So part dx would be a vertical slice. So I'm going to move it over here. And that's going to be parallel to the axis rotation. So that's going to be a shell. So don't just assume dx is always just washers. Here it is. It's a shell. So the volume is 2 pi r h dx. We're going to integrate in the y direction, the x direction, 0 to 4. The radius is x right minus x left. So for shells, remember it's just going to be whatever x are at minus x left is 0. It's just going to be x. The height, that's where the curves come in. That's y top minus y bottom. Y top is 2, no matter what, all the time. Y bottom is the square root of x. So that's your setup. B is going to be dy. It's going to be horizontal slices. So we could do it down here, and what we get is a simple disk. Really simple. Pi r squared dy. So in the y direction, we have to integrate bottom to top, 0 to 2. The radius is x right minus x left. X right in terms of y is a y squared. X left is 0. So it's going to be a y squared squared again dy. So let's plug them into our calculator. See if we get it. 2 pi math 9 x parentheses 2 minus the square root of x close parentheses comma x comma 0 comma 4. It's 20.106 round truncated 3 decimal places. Same. I'm going to do pi math 9 x to the 4th. I'm just going to do that, comma x comma 0 comma 2. Same answer. Okay, so we get, we should be getting the hang of this, but doing these and just going through the motions. Don't memorize these formulas. Draw good pictures. Think of the basic geometry. That's going to be what's going to help you get them right now and remember it in the long run. Okay, last one. Let's draw a picture. Part A is going to be dx, which will be vertical slices, which will be shells because it's parallel to the axis of rotation. You should know, oh, these are parallel to the axis of rotation, so it's going to be a shell. The volume is 2 pi r h dx. The limits in the x direction are always going to be based off this region alone, 0 to 2. The radius is x right minus x left. X right is whatever x value we're at for shells, minus -3. So it's going to be x plus 3. The height is the thing that is dependent on the curves, y top minus y bottom. So y top is 4x and y bottom is 2x squared. So that's our setup for that one. And B is going to be dy. So dy is going to be horizontal slices, and they're perpendicular to the axis of rotation this time. So we know we're going to get these disks or washers. So pi r squared dy minus pi little r squared dy. In the y direction, I'm going 0 to 8. So the big radius is x right minus x left. Now x right, in terms of y, we divide by 2, right? And then we take the square root of both sides, plus or minus. So we're going to do with the positive square root of y over 2. The divided by 2 is inside of it. So it's square root of y over 2 minus -3 squared. The little radius for the whole is going to be x right minus x left. It's going to be this x coordinate in terms of y, which should be y over 4, minus y left, x left is -3. If I change the minuses, pluses. Now let's plug these into our calculator and see if we got them right. 2 pi math 9 parentheses x plus 3, close parentheses, 4x minus 2x squared, close parentheses, comma x, comma 0, comma 2, 67.020 or 67.021 if you're into rounding. Let's try the other one. Pi, math 9, parentheses, square root of x divided by 2, all inside the square root, plus 3, close squared, comma x, comma 0, comma 8, minus pi, math 9, parentheses, x divided by 4, plus 3, close parentheses squared, comma x, comma 0, comma 8. I'm going really fast. Hopefully I don't make any mistakes. But I'll know very soon if I typed it in wrong or something. 67.020. Perfect. Same answer. 67.021 if you want to round. So that's it. You guys got to get good at these. You got to be able to crank these out. I mean, these should be straightforward problems. I know they're kind of messy. There's a lot going on. If you can draw a good picture and keep the geometry in mind, you should get these 100% right every time if you're careful. There's nothing weird, deep philosophical, explanations, justifications, different. I mean, it's the same approach every time. Okay. So you can get really good at these if you're good with the details. So let's do it.